Before we start our next keynote presentation, I would like to thank Microsoft for being our preservation sponsor at SAVE 2024. So how can we advance sustainability, taking care of our own environmental footprint, delivering digital technology to net zero, enabling a more sustainable world? Microsoft's sustainability journey to be carbon negative, water positive, zero waste, and protect our ecosystems. Here is a quote from their environmental sustainability report: "To move from pledges to progress, we cannot be deterred by near-term challenges and must remain focused on developing innovative new solutions and in many cases accelerating our actions. At Microsoft, we are deeply committed to sustainability as a company, as a technology provider, and as citizens to planet Earth." And I want to introduce Karen Alvarez from Microsoft, who's come to join us here today.
Thank you so much, Christina. Microsoft is super proud to be the preservation sponsor for the SAVE AV conference of 2024. And I want to thank the entire SAVE AV team for organizing and bringing everyone together for this conference. I think that everyone that is here today cares very deeply about this goal of achieving all of the SDGs by 2030. I think that everyone here today is a leader in their own right, and change is happening here today, right? I think that ideas are getting discussed, we're getting the ball rolling, change is happening as we discuss and talk with each other on what can we do to advance sustainability, especially in our industry, right? Sustainability, there's so many different areas in which we could be working in, but we're tackling this together for the AV industry. And I think that it's also great that we're hosting it at UCLA, right? Not just because of everything they're doing to advance sustainability, which Joe shared earlier, but also because we're surrounded by students and we're surrounded by kind of a younger generation who will keep this ball rolling and will take these goals even further, right? So as the Chief Sustainability Officer shared earlier, this is a long goal. We're gonna be working at this for a while. And it's not just gonna be us, it's gonna be the people that follow us. So it'll be amazing to see what we can do in these 2 days and what comes out of it on the other end as we continue to advance towards our goal. So thank you again for organizing this, and I'm excited to talk to everybody and see what we can do to advance this goal even further. Thank you, Christina.
Thank you. Really good. Karen. Picture, Karen. Picture, sorry.
I thought you were like, time to go. Thank you so much.
Thank you. I'm very excited about our next keynote presentation entitled they're controlling AV electronic waste. There's no way when you throw it away. As we learned in our last presentation about bringing the SDGs to the AV industry, sustainability can only be achieved by accomplishing the Sustainable Development Goals as they are intertwined, inexorably connected. Each impacts all the others. But we as a technology industry, our impact on sustainability falls more heavily in certain areas. And so our efforts at remediation, I refer specifically to the SDG 12, responsible consumption and production, from the way that we source resources and products to the way we handle them at the end of the solution's lifespan. The AV industry has a huge impact on key drivers of this crisis. Here to fill us in, coming all the way from Bogota, Colombia, on the nature and scope of the problem, is Carlos Hernandez, Latin America Coordinator of the UNIDO GEF program. Trained as a chemical engineer, Carlos holds a master's degree in environmental engineering from the National University of Colombia. He has 27 years of professional experience as an environmental consultant in the areas of air pollution, cleaner production, and the environmentally sound management of persistent organic pollutants in electrical and electronic waste. Carlos brings his experience to Latin American countries as part of the United Nations Industrial Development Organization and Global Environmental Fund, and we are very fortunate to have him here to share some of his knowledge with us. Thank you, Carlos.
Well, good morning, everyone. Thank you, Christina, for the introduction, and thank you for the invitation to this Congress. I'm very happy to stay here and sharing with you some ideas. I have to confess that I'm not used to present in English, but when Christina told me, she convinced me, and I'm a fan of this kind of initiatives, so I'm happy to be here. Just in case you can understand something that I'm trying to explain, just please don't be shy to interrupt me, and I explain it. But thank you very much to be here, and I'm happy to know that we have some industry representatives here which demonstrate the commitment of the industry, which is really a high need in this regard. So I would like to begin explaining some concepts. This is the agenda that I propose to this next hour. First of all, I would like to go through the basic concepts just to be sure that we are all in the same page, and then some characteristics for e-waste that I consider are very, very important in order to understand why they are so special in terms of their composition. And then some of the big issues that I would like to go through. For example, the environmental and health impact that the mismanagement of e-waste causes, and also the increase which Joe referred before. But I would like to stress some aspects. And then how we can really contribute to the sustainability, the AV industry, and finally with some messages that I would like to share with you. I hope we have some time for Q&A at the end. So first of all, I would like to begin explaining what we understand for we and we understand for E. E stands for electrical and electronic equipment, whereas e-waste or we stands for weights of electrical and electronic equipment. How do we go from E to E? E, as you can see in the bottom of the slide, some of you for sure have many of these devices in your houses. For example, TV sets, cell phones, washing machines, cameras, electric toys, and so many of these devices and appliances that for sure you have. So the question here is how many of these stuff that you have in your house are just keep it in a table or in a closet or wherever. As many of these devices that we don't use is a waste. So beginning for the definition of what E is, E is any device or any appliance that depend on electric current to function properly. That is the important and the key word here, function properly. And the definition of E also includes all equipment used for the generation, measurement of just current and fields. So for defining what waste is, we need to define, we need to be very careful of what the definition of the country, because each country defines waste in a different way. So it is by law, this definition. But according to the European Commission, waste is defined as any substance or object that which the holder dispose of is required to dispose of. So why waste is discarded? Waste is discarded because holders do not use the products anymore, or because they are defective or obsolete. But something important here is that most of us discard an object even if they are functional, but we discard because by fashion, because we are the last technology, because we want a better camera, for example, in our cell phones or something like that, even if the product of the device is functional. But in that case, this cell phone or the device that we discard becomes a waste. So waste is E, which has become waste according to the national definition that we have in the respective countries. So there are thousands and thousands of these devices and appliances, so it's necessary to classify them in categories, and this is the categories that the European directive proposes. So this classification responds, for example, to size, to weight, but also to the composition and also to the functionality of these appliances and devices. The first one is for temperature exchange equipment. For example, freezers, refrigerators, heat pumps, and so others. The second one is for screens. You have here screens, television sets, laptops, notebooks. The third is for lamps, for example, the high-density lamps, and also LED lamps. And you see in red some equipment devices that maybe you are familiar with them in the AV industry. The fourth one is for large equipment, where you can find equipment reproducing sound images. The fifth is small equipment. You have here ventilation equipment, video cameras, video recorders, hi-fi equipment reproducing sound or images. So maybe in this category fall many of the appliances or devices that you use in the AV industry. And finally, the sixth is for small IT and telecommunication equipment. So why e-waste is an important or different type of waste? And the reason is because of their composition. The composition is what makes the difference between e-waste and other type of residue. That's why some legislation in some countries classify e-waste as a hazardous waste, but others, for example, in Colombia and most countries in Latin America, classify this as a special waste. So, but it doesn't matter the classification in this case. The composition of most of the equipment that you see, as you can see here, most of them are made of metals, precious metals, ferrous metals, non-ferrous metals, plastics, for example, ABS, HIPs, ABS, and others, cables, glass, printed circuit boards, pollutants, and other materials. So the composition is more or less similar, but of course it varies from equipment to equipment. For example, you can see here that LCD monitors have more glass. Glasses, okay, in CRT TVs sets, glass is very, very important, almost 65%. In LCD monitors, they have more metals than other type of equipments, but of course the composition varies from category and from equipment to equipment, but more or less the main materials are those that we can see here. Well, in terms of recycling, it is important to consider that some materials, for example, the iron, aluminum, copper, and also silver, can be recovered at a profit. But others must be disposed of at a cost. For example, batteries, CRT, glass, capacitors, and others, they need, recyclers need to pay for disposal in the safe way, this kind of material. So that's why everyone wants to recycle, for example, laptops, cell phones, and things that really are very interesting from the economical point of view. And the other thing that is important in terms of implementing a recycling system is that the design and monitoring this recycling system is crucial to know the material composition of waste, because it has to do with the business model. Then when you can see here is surprising that almost all the elements of the periodic table are present in these devices and in these appliances. You can see that in that case, we can find very, very hazardous elements that are present in these devices and these appliances. Some other elements are considered critical, and I will refer to later about these critical materials or critical elements, and some of them are very, very valuable as well. So in this case, we can see precious metals, for example, that are present. We can find silver, gold, platinum, and palladium in printed wiring boards, or printed circuit boards as well is known, and connectors. And copper, for example, we can find copper in motors and cables. Some of the rare elements, those that are in the bottom of the periodic table, for example, neodymium, dysprosium, and yttrium, they are used, or they are found in the hard disk drives, speakers, and as permanent magnets. The yttrium, for example, are found in the phosphorus in the cathode ray tubes. Other critical materials, for example, cobalt, lithium, indium, they are found in batteries, and the main important here is the more important thing here is the hazardous substances. So we can find, and we should be very careful about these hazardous substances, because we can find these, for example, polychlorinated biphenyls, PCBs, in capacitors, transformers, the older ones. We can see CFCs in refrigerants, brominated flame retardants in plastics. We can find mercury in fluorescent lamps and some switches. Lead are found in batteries, CRT glass, and also cadmium in batteries, toners, and plastics. So this is the two phases of the e-waste. One good phase, let's say, which we can find precious metals and some other metals of economical importance. But on the other hand, these hazardous materials are a matter of concern. About generation, Joe already mentioned that at the global level, the global e-waste generation in 2019 was about 54 million tons, according to the UN Waste Monitor, which means a rate of 7 kilograms per capita as an average in the world. So it is important, this average. For example, do you know what is the average, the per capita generation in the US? It is almost 22 kilos per person year. So which means it's 3 times the average in the world. So it is something that we really need to think about it. And the other matter of concern is that just the 17%, as Joe mentioned as well, is reported formally collected and properly recycled. So we don't know what is happening with the remaining 83%. Maybe part of this 83% is in warehouses, is on our homes, as I said before. Maybe some part of this 83% is dumped, is landfilled, and maybe some of this percentage, a great percentage, I would say, is exported illegally to other countries. So that's an important thing that we need to think about. If we were able to collect all the 54 million tons that are generated in the world, we are talking about $57 billion. So represented in materials, for example, aluminum, copper, iron, and so others. So this is important to think. But with the remaining 83%, you can see here, we don't know what is happening with that, but in that case, it could represent 71 kilotons of brominated flame retardants and 50 tons of mercury, for example. So it's a matter of concern. Here we have where we can find these toxic substances. And these toxic substances comes from where we call the hazardous fractions. Hazardous fractions are those fractions that are really a matter of concern in recycling industry. For example, the printed whiteboards, they contain brominated flame retardants, they contain lead, beryllium, and also mercury. We can find capacitors that contain polychlorinated biphenyls. We can find CRTs with lead, cadmium, barium, and so on. So this is the issue in recycling industry, and this is the things that we think really about, because of course it is a source of contamination for not only for the environment but also for human health. So one of the problems that I see with weed management, I call the first problem is the negative environmental impact of weed mismanagement. And here we can see some of the familiar, some pictures that for sure you are familiar with. But we can see here, for example, open burning of cables. So it's a common practice in developing countries where people want to get advantage of the copper in these cables and other appliances. So open burning is one of the worst practices, but unfortunately it is followed in some developing countries. Also, you can see in this site where this kind of practices, people smelt, for example, aluminum or printed circuit boards in order to get in the case of printed circuit boards, they want to get the gold containing in these boards. So this is one of the worst practices that are followed, unfortunately, in developing countries where most of these e-waste are sent. And the issue here is that these countries doesn't have technology, doesn't have knowledge, doesn't have infrastructure to deal with this problem. So what unfortunately we see that is happening in the world is that there is illegal movements. You can see in this case the green arrows shows the flows that follow the Basel Convention rules. It means that they have the prior informed consent to be sent to other countries. But in red, you see those flows that are uncontrolled, I would say illegal movements of e-waste around the world. So most of these flows, as you see, come from developed countries to developing countries. So it's a big issue, and again, developing countries doesn't have the technology, knowledge, or infrastructure to deal with this issue. So this is one of the biggest problems, and this is why we find this picture that we saw before. From the environmental point of view, there are some impacts. For example, we have dumping, leachates, we have burning of cables, which produces fumes, leaching, which produces effluents. This practices of cooking, where they are trying to smelt aluminum, copper, or other metals that produce fly and ashes, and so on. You can see some of the effects, the negative environmental effects due to these mismanagement practices of e-waste. So there are, of course, global effects as well. And in this case, let's think about if we are not able to recycle e-waste, we need to mining from primary deposits the materials. So it is important to think about it. Just imagine that in the case of laptop, for example, in the manufacturing of laptop, it is emitted more or less 150 kilos of CO2 equivalent. And 80% of this CO2 equivalent is due to the manufacture of the laptop. The remaining 20% is just by the use of the laptop, considering 3 years useful life of a laptop. So it means that we would need to use a laptop for at least 12 years in order to annul, that's correct the word, to annul the CO2. That is things that we need to think about. So global warming is an issue, but e-waste management can contribute to control the global warming by recycling, by extending the useful life of our products. So if we don't recycle, of course, we cannot reduce greenhouse gas emissions due to the extraction and refining of primary raw materials. For sure, you know that most of refrigerants are found as well in some temperature change equipment, and some of them are greenhouse gases as well. For example, maybe you know that some of the CFCs and HFCs has changed to hydrocarbons as refrigerants. For example, the what's the name? Cyclodecan. Cyclodecan, I think it's the refrigerant that is used instead of the CFCs. And in this case, this is a greenhouse gas. So according to the International Energy Agency, a total of 98 million tons of CO2 equivalents were released into the atmosphere from discarded fridges and air conditioners. So it is an important issue as well. So the second problem that I would like to refer to is the effects, the negative effects on human health. Maybe you can imagine with the before slides that it affects as well the human health. And human health are represented here. The mismanagement of the waste affect the neurodevelopmental, has neurodevelopmental effects. For example, decreasing the memory and the learning processes, reduce the IQ, at endocrine level, they causes obesity, suspicious for obesity, but alter the thyroid hormone. At the reproductive level, they decrease the fertility, decrease birth weight, decrease the sperm quality, but also some of these pollutants are very suspicious to be the cause of diabetes or cancer. So these pictures that we see in this side, these are taken in some Latin American countries, unfortunately, where the problem is not as big as in Africa, for example, but the problem exists as well in our countries. And the third problem is the problem that Joe talked before about the rapid increase of at the global level. So on the left, you can see the e-waste generation per category, and again, you can see that small equipment is the largest contribution, to the e-waste generation at the global level, with almost the 30% of the global generation. So on the right, you can see that in 2014, e-waste generation was about 54 million tons. Then in 2019, it increased up to 54 million tons, and it is expected that in 2030, this amount should be almost 75%. So I don't know if you can imagine how much is 75 million tons by 2030. Just to put it in context, this 75 million tons is like if you have here 200 Empire State Building, more or less. That's the comparison. So it's an important amount. Well, we saw that at the global level, it is generated about this 54 million tons in the world, and Asia is the champion here in e-waste generation with almost 25 million tons, and then we Americas we generate about 13 million tons. Americas means North America, Central America, and South America. And the question here is why this generation? There are many reasons. One of them is because we have higher levels of incomes. Another reason is the urbanization. Another is the industrialization. But there are other causes, for example, this related with either consumer habits. The short life cycle is an important thing here, and it's something from the point of view of producers that we need to work on. And unfortunately, we have in some countries just a few repair options as well. So these are some of the causes of this generation and these amounts. As said before, one of the matter of concerns is that only the 17% is reported as formally collected and recycled. And the champion here in collection, informal collection, I mean, is Europe with almost the 43%. Then it's followed by but Asia with almost the 12%, and then we are in the third place, informal collection. So we are missing many opportunities, but also we are generating some risks to the health and to the environment. In this case, because we don't know, in the case of Americas, we don't know what is happening with almost the 90% of the e-waste generated. So e-waste management represents really a contribution to the e-waste, to the SDGs. Almost the 17 SDGs are represented in the e-waste management, and the contribution is really high. Fighting against the poverty and creating green employees, for example, but also welfare. But in particular, these two SDGs, SDG 11, explicitly say that it is particularly important to properly manage e-waste in urban areas, improve collection and recycling rates, and also reduce the amount of e-waste that ends up in dump sites. On the other hand, the SDG 12 says that it is critical to make production and consumption more sustainable by raising awareness levels, both in producers and consumers. It is important in the area of electrical and electronic equipment. So these two SDGs in particular brings our attention to forced or enforce the e-waste legislation, of course, and the e-waste management around the world. The other thing that I would like to talk in this moment is that we right now are losing resources due to inappropriate waste management activities. So how we can reduce these lost resources and how we can contribute to e-waste management to the sustainability. This is a picture and information that Umicore is one of the largest refining companies around the world, based in Belgium. And they said that from a primary deposit, we can get as much as 5 grams of gold per ton of soil removed. But if we were able to collect 1 ton of mobile phones, we were able to get up to 300 grams of gold. So it means that from mobile phones, recycling mobile phones, we can get 60 or 70 times more gold than from the primary deposit. So that is why the e-waste is called the urban mine, because they are many resources, valuable resources that we can take advantage of. In this graphic, we have an example for palladium, gold, and silver. The line in blue shows the global demand. Then the green represents how much we are recycling for these 3 metals, and the blue represents how much we are mining. So, on 3 conclusions we can have for this analysis. The first one is that recycling does not cover the global demand for these metals. The second is that supply from sustainable and approved primary resources remains very important. And the third one is that we really need to recycling more. We need to increase recycling rates if we want to be sustainable. Just for these 3 examples. But I like this one because it shows again the importance of these elements in the electronic industry and how able we are recycling these elements. In blue, you can see that we are really efficient recycling, for example, copper, gold, silver, nickel, and these other metals. But on the other side, you can see those in red, where recycling rates are less than the 1%. So we are missing these metals in red, for example, lithium, beryllium, barium, gallium, germanium, indium, and so on. And those of considered rare earth metals, cesium, praseodymium, neodymium, europium, and so on. So why these metals are important? Just consider that we are recycling less than 1% of those in red. So the importance of these elements is that they are used in the emerging technologies and have different applications. For example, in energy technologies, the gallium, the indium, the lithium, and in eolic energies, for example, the dysprosium, neodymium, praseodymium are used, and in catalytic converters, for example, almost of the red ones, the cesium, gallium, cadmium, and so on, are used in these applications. For telecommunications and optical cables, the erbium and germanium are very used. And for optical applications, medical applications, germanium, niobium, tantalum, and so on, europium, and so on, they are very important. And also for ICT technologies, dysprosium, neodymium, praseodymium, and others are useful. So the question here is how we are going to be able to sustain the future of the electronic in this case if we are not recycling these elements and taking into account that our resources are very, very, very limited. In the case of indium, for example, is a very interesting case. A friend of mine, Chilean friend of mine, is doing her doctoral thesis on indium and the importance of indium in solar panels. And according to his research, indium will be enough, as a primary resource until 2030. If we want to change of the energy demand only with solar panels. So we don't have enough indium if we would like to use solar panels to cover the global demand of energy. So this is an important thing. And this shows that these rare elements are important and very used because they have these magnetic, luminescent, and electromechanical properties that allow the development of technologies with lower weight, high performance, speed, durability, and thermal stability. The europium, for example, are used for sharper TV image. Yttrium are used in lasers, TV sets, energy-saving light bulbs. Erbium for telecommunications and fiber optics. Neodymium is the responsible for the miniaturization of equipment. And I don't have here the indium again, but indium is, for example, responsible for the touch technologies, so used in our cell phones, for example. So these elements are really, really important. And again, we are not recycling more than 1% of these elements. In this chart, I like to show something that the European Commission released on an annual basis, and it is called the critical raw materials. So this is called critical because two characteristics. The first one is because these materials have high risks in the supply chain. The supply chain can be disrupted if we don't have enough supply of these elements, and the supply, because the supply comes from very few suppliers or from very few countries. And the second criterion is their high economic importance. They are essential for the global economy and for a wide range of industry and technologies. And again, you can see here that in this critical raw material chart, we can find the rare earth minerals, we can find niobium, we can find magnesium, but also we can find cobalt, strontium, the metals of the group of the platinum, and another one. So this is really a matter of concern in this case with these critical raw materials, because they have, as I said before, strategical applications. And this is how much we depend from the supply of these elements. For example, in the case of niobium, Brazil provides us at the global level with the 92% of niobium. The Democratic Republic of Congo is important supplying the cobalt used for lithium-ion batteries. South Africa is very important supplying iridium and also ruthenium with more than 90%. But I think the critical case is China. China, as you can see here, provides us 94% of gallium, 83% of germanium, but almost the 7% actually in heavy rare earth metals and light rare earth elements. So we depend very, very largely with the supply from China, and this is a geopolitical issue. Maybe you heard about the news months ago, a year ago, I think, with this fight against the U.S. and China. That the first thing that China did was they stopped exports of these kind of metals. So this is a very important issue at the geopolitical level. Let's see the case of the lithium. Lithium, as I said before, is very used in ion lithium batteries. These batteries are used in cell phones, are used in laptops, are used in electronic vehicles, EV mobility in general. So they are very important in our day-to-day activities. So in the case of lithium, we need the lithium carbonate for the cathode of these batteries, but also in the electrolyte of the batteries are used. But it has a very important environmental impact. For example, the water consumption for producing just 1 kilo of lithium, it's about 400 to 2 million liters of water. And consider that an electric car needs about 7.5 kilos of lithium. Refining lithium requires the use of chemical substances, so it causes water pollution, but also there is another social impact here that we need to keep in mind, that is exploitation, child labor, and many others social injustice that occur around this exploitation. In YouTube, you can find a very interesting video on the exploitation of cobalt in the Republic Democratic of Congo. I would like you to recommend this video because it's really impacting for me. So there is many issues around these problems. So what can we do? We know more or less, I hope, the situation, what the problems are, but what can we do? And I think that the speakers that talked before me, they highlight the importance of the participation of all actors. I think it's very important, and again, establish a collaborative effort with all stakeholders, in this case, to help the AV industry professionals address the impact of their e-waste. I learned this morning that the AV has these effective e-waste sustainability programs that are easy to articulate with stakeholders. So consider to become a SAFE certificate. I think that it is important in this case as an immediate action that we can take. At policy level, I think that we can force to create these regulations, the EPR, the extended producer responsibility. I think that it is important and powerful tool that has proved that is very useful regarding the waste management around the world. The EPR is applied in most of the European countries, but also in Latin American countries. Unfortunately, in Latin America, we just have 3 countries, which are Ecuador, Colombia, of course, Costa Rica, that are implementing this scheme. But other countries, for example, Uruguay, Chile, Argentina, and so others are working in this regard. So their legislation are based on the EPR, not only for e-waste, but for other waste as well. For example, textiles, tires, and so on. But this is a very important and powerful tool that I really recommend. I know that here in the U.S., about half of the states in the U.S. have implemented some of these policies as well. But what about the other 25 states? So I think it's important to push these kind of policies. We need, of course, incentives for circular economy, incentives that really works, incentives for all the stakeholders to really implement these practices. We need incentives for recyclers. Recyclers right now, they are just focused on currents, rich in metals such as steel, aluminum, copper, but they are not paying attention about the rare earth metals, for example, precious metal, or even plastics. So plastics are a very important fraction of e-waste, and I think we are missing these opportunities, and this is part of the circular economy as well. And level policy, of course, we need incentives for repairing. I think that the right to repair is a very powerful policy as well. I know that Minnesota, Colorado, and I think New York, maybe the state of New York, has implemented this policy, the right to repair. But these kind of policies, I think, really contribute to the sustainability, in this case of the AV industry. We need technical standards to protect or e-waste and its components in all stages of e-waste management and promote the use of materials. Many recycling companies here in the US follow the R2 standard. It's important. This is not the only one, but this is one of the most spread around the country. So it is important to follow this kind of standards. We have also e-stewards here in the US, and the European level we have the Senelec standards that are very important. In South America, we are working on that as well. We have followed the European model with the Senelec standards. In the case of Peru, they have national Peruvian standards as well. So standards are very, very necessary to promote really the circular economy and the sustainability. But again, in this case, SAFE has developed a program for repurposing and reusing AV equipment involving NGOs and also educational institutions to enable companies to give a second life to their products. So it is important to join these programs. I think it's an opportunity that we have, and it's an immediate action that we can take in the next months. We need the communication, information, and awareness campaigns for users. So I think this is one of the weaknesses in our countries. Most of the time, I would say I would like to return my equipment. We are responsible consumers, but we don't know how to do what to do with our devices. So I think that it is very necessary to inform public about what to do and give formal channels in order that they can return their devices. So we need to build these kind of channels and give us the opportunity to return our devices. Communication and information campaigns and strategies are very, very necessary in this case. I would say it is the most difficult thing in any system, management system. I heard, for example, in Germany, about 70% of people didn't know that in Germany exists these formal channels that allow them to return their devices. So we are talking about Germany, we are talking about Europe, and they started to implement their management system since 2000, more or less. So we are talking about 24 years, and people, some people don't know that this kind of channels exist. So it's one of the most difficult things, but we need to start with these strategies as well. And statistical data is something that is really, really necessary. We can't tackle any problem we don't know the magnitude of the problem. And this is, I would say, the critical case here in specifically in the AV industry. We don't know how much is put on the market. We don't know how much is produce hazardous waste. We don't know where it goes. We don't know how much is imported or how much is produced here, or maybe the information exists, but it is not easy or publicly available. So data is very, very important in order to plan strategies and to plan policies on what to do. Regarding the management systems, I think it's important to take into account that the current model is that once we produce our end-of-life products, they are collected, if we are lucky, they are collected by the systems, and then this collection is sent to pre-processing. What's wrong? And then here the products, the equipment are disassembled, dismantled, and then the fractions are sent to end processing. So the proposal here is that before send the collected equipment to pre-processing, we need to think first on reuse the equipment, reuse the elements, refurbish them, remanufacture, and finally, as a last option, recycling. So this is one of the actions that we, or recyclers, can take, and so the functionality of the product, but also the functionality of the components are not missing. So extending the lifespan of electronics or reusing their components provides even greater economic benefits. Most of recyclers in Latin America are doing that. They prefer to reuse, to repair, to refurbish before recycling, because they have learned that it is more profitable than just sending or recycling or selling these parts of components. So it is an important thing that we can also implement. And it is how we can play with the arts of the circular economy. Of course, the arts plays into ways from the consumer point of view, but also from the producer point of view. For example, when we talk about reject, we as consumers can think twice before purchasing a device and ask ourselves if we really need a new one. So this is the first thing, because again, we usually change, for example, our cell phones just because we want the new technology, but it is functional. So this is the first thing as preventive action. And then the second one is about to rethink and reduce. Rethink and reduce, again, this is for producers, but also for us as consumers. In the case of producers, they can rethink and reduce. I mean, they have to be very careful with the design, what they are putting into their devices. And from our point of view, I think that as consumers, we rethink, we have to prioritize, let's say, green products that have this kind of certification. For example, the TCO, you can Google afterwards this certification. Maybe some of you know what is TCO. But this is a kind of certification together with EPIT that tell us what products are more green than others. For example, if you want to buy a laptop, you want to buy a cell phone, you can find the brands in these links, and they say how sustainable is the product that I want to buy. How sustainable in terms, for example, of water footprint, CO2 footprint, energy efficiency, and other criteria that are very important in order to make decisions of what to buy. And also, as we as consumers can prefer this kind of product with this kind of certification of labels. For example, the Roche is a WEEE directive, a European WEEE directive, actually, for restriction on hazardous substances. And this directive limits or restricts the use of certain chemicals, for example, mercury, lead, flame retardants, and others, PFAS as well. So some of these, many of these equipment, you can see the label in this part with this Roche label. So it allows us to make better decisions. I don't want to go through all the R's. This is for you, this presentation. I just want to mention some examples. But for example, in the case of repair, we think it would be very desirable that we think repairing products instead of throwing them away. So it reduces waste and conserves resources. There are, again, some examples here. There are some initiatives. One of them is the iFixit. iFixit is a website that for sure you are familiar with that as well, where you can find manuals and also you can buy the tools for repairing your cell phone, for example. And also another initiative, this is the Fair Phone, which this is a phone that are designed in parts, so you can replace just one part and avoid to buy a cell phone. Most of the cell phones, the laptops and other electronics, we need to change them because the battery is not function anymore, or the screen is broken or something like that. So in that cases, we can prefer this type of equipment that are easy to repair, and so that we can extend the lifespan. And so on. You can find here that we can play with these R's from the consumer point of view, but also from the producer point of view. From the producer point of view, I think that is very, very important. Rethink the design. I think it's one of the main issues that I would like to stress here, because most of the equipment that we find today in recycling plants are equipment that are very difficult to disassemble, are equipment that have a lot of chemical substances, are equipment that is many cables, glues, and things that can make almost impossible to disassemble the parts and take advantage of them. So the design, I think, is the most important thing here from the point of view of recyclers. In UNIDO, we are pleased to collaborate and to support projects with the approach to circular economy aimed at getting products that last and maintain their value as long as possible, that minimize the waste and pollution, and that prioritize renewable energy along the value chains. And I think that it can achieve by these enablers like innovation, digitalization, stewardship, partnership, and collaboration among the parts. So again, the collaboration between businesses, governments, consumers are very, very important. Final thoughts that I would like to share with you. We have just one planet. By 2025, the world will be consuming as if we were three. Regarding the designing, 90% of biodiversity loss is caused by resource extraction and processing. Up to 80% of products' environmental impacts are determined at the design phase. And in the case of the European Union, only the 11.8% the current circular material use rate. So this is one of the things that I want to share with you. And finally, some takeaway messages that I would like you to share with your family, with your friends, with your partners. It is not just for you. I think that in this kind of congresses, spaces, we are familiar with these concepts, but we don't, and sometimes we don't share that concepts with our relatives. So I think it's very important that share with them these things. So e-waste represents a very, very important source of resources, raw materials, green employment, economic opportunities, but it is important to keep in mind that its management generates serious health and environmental problems, that we should worry about how products are designed and what substances are added to them. And as responsible consumers, we should always choose sustainable equipment and be responsible. And finally, that we can contribute to the reduction of greenhouse gases and also with the climate change. And the positive impact on CO2 by maximizing the useful life of our equipment is very, very relevant. So any actions count here. So don't underestimate what you can do. And I would say finally that the solution is on our hands.